This video is on functions as models. So models describe ideas to explain our observations of the world. Often equations need to be created based on information given. And you'll often see this within the IB on the harder questions within an exam where you have to start creating your own equations and manipulating them to get what is required. First example, you need to make an open rectangular box with a volume of 2 meters cubed and a square base. So we want to show that h equals 2 divided by x squared. Now something to be really aware of here is in a show that question, you are not allowed to start with the answer and work backwards. That h equals 2 over x squared has to be the final answer. It cannot be used earlier on in the manipulation process. So with these questions, often it's really difficult to know where to start. So always just look at the information you've been given in the question and go with that. So we know we've got a rectangular box and a volume of 2 meters cubed. So the volume of a rectangular box is length times width times height. We know the volume is 2 meters cubed, so that would be 2 equals. Then we have length is x, and a height. So if we simplify that, we're going to have 2 equals x squared times h. Then we want the h on its own, so we can divide the 2 by the x squared to get h equals 2 over x squared. Now part B, find a model to express the surface area in terms of x. We're going to go back to the question, and the important bit here is it says you need to make an open rectangular box, which means there's no lid. So for the surface area, we need the base. So the surface area, we'll need the base, which is x squared, plus we've got all 4 long sides, which to find the area of that is x times h, and we have 4 of those. If we simplify this down, then we have x squared plus 4xh. Now, in the question, it says express the surface area in terms of x. When it says in terms of x, what that means is we are only allowed x as a variable within our equation. At the moment, we've got x and we have h. So what we can do here is we can replace the h with 2 over x squared, because we know from the last part that h equals 2 over x squared. And then we can just simplify this down. So we'll have x squared plus 4 times 2 is 8. And then we've got x divided by x squared, which means we'll end up with 8 on x. And that is a model for the surface area. Then part C, we want to find the surface area when the length of the square base is 10 meters. So that is telling us that x equals 10. And so we can just sub that in. So the surface area will equal 10 squared plus 8 divided by 10. Just put that into your calculator and we will end up with an answer of 100.8 meters squared for our surface area. Next example, a team of architects have asked for a model to be created for the area of a window with the following requirements. The window should be rectangular with a semicircle placed on top. The perimeter of the window is equal to 30 feet. Part A, draw a sketch of the window where x is the width, h is the height of the rectangle, and r is the radius of the semicircle. So part A, draw a sketch. So we know we've got a rectangle with a semicircle on top, so we just draw this best you can, and then where x is the width, the x there, h is the height of the rectangle, and r is the radius. So the radius will be there. Part B, express the radius as a function in terms of x, which means we need an r equals and only x in the equation after that. With this, we know that the radius is half the width, therefore the radius would be equal to x on 2, because we know that x is the width of this rectangle, which is also the width of the semicircle, so the radius must be half of that. Part C, show the height h can be expressed as h equals 15 minus 2 plus pi, all multiplied by x, divided by 4. With this, we need to go back to the question and see what information we've been given. So in the question, we are told that the perimeter is equal to 30 foot. So we need to make an equation for the perimeter of this window. So the perimeter will equal we're going to have 1x, which is the base, plus 2h either side. And then we have the semicircle, which will be half the circumference of a circle, so it will be half 2 pi r. Then we can start simplifying this. So we know the perimeter is 30, so that's going to be 30 equals x plus 2h plus half times 2 is just 1. So then we're going to have pi. And we know that r from part B is x on 2. Now from here, we need to be able to rearrange this to look like what we've been told in the question. So x plus 2h, this would just be x pi on 2. So we need h on its own. So we can rearrange this to be 2h equals, then we'll have the 30 minus the x minus x pi on 2. Now, if you're looking at this equation here, we only have 1x, so we have to be able to factorize. So 2h would equal 30. Now, to do the x minus x pi on 2, we need both x's to be on 2. They need to have the common denominator. So this would be 2x on 2 minus x pi on 2. And now from here, we can combine those two fractions. So we'll have 2x minus x pi on 2. And then we can factorize out the x. So we'll have 2 minus pi multiplied by x on 2. Now we need h on its own, so we need to divide everything here by 2, which will give us 15 minus 2 minus pi all multiplied by x divided by 4. So it's a bit of manipulation that is required there. And as I said previously, you'll often see this type of thing in the later questions in an exam because they really want to test your understanding. And then part D, we want to create a mathematical model that describes the area of the window in terms of x. So I'm just going to go over here for D. So area of the window. How we find the area of this? The area would be area of the rectangle, which would just be x times h, plus the area of the semicircle, which would be half pi r squared, because it's half a circle. Now we want the area of the window in terms of x, which means now we need to look at all our variables. So we've got the x, h, we know what h needs to be from the last example. So it'll be x times 15 minus 2 minus pi multiplied by x on 4 plus the half pi, and then r we know from part B is x on 2. So x on 2 all squared. And then from here we need to simplify where we can. We could expand the x here if we wanted to. So we get 15x minus 2 minus pi x squared on 4 plus, and then here the half pi will stay, and then when we've got to square out outside the brackets, we square the top and the bottom back to our index laws, and then we can just simplify this here, which would give us with pi x squared on 8. Now this first section here, if you'd left that with the brackets around it, that would be fine because it is simplified. There's nothing else that we can simplify within it. Unlike the second part where we had two fractions and things like that, so that could be simplified further. And that is functions as models.